All right, so let's take a look here. I think this is recording. Problem 4 is a polynomial function of degree 4, and that's an even number. And the leading coefficient the number that's in front of x when it has x to the fourth is 2, and that's positive. So since it has a positive leading coefficient, it's going up to the right, and since it's an even degree, the end behavior is together. So this time it's going both positive and positive. So that's Roman numeral 1. When it's in standard form, the y-intercept is always going to be the constant term, because all these other terms are going to be 0 when you input 0. So the y-intercept has coordinates of 0, 2 for this problem. We don't have any greatest common factor here to factor out. This list is the wrong list. It should not have 3 in it there. Let's see. Yeah, just 1, 2, and 1/2. Sorry about that. I'll show you how to generate this list, and you will be expected to be able to generate it. But for now, I'm just giving it to you. So we have to check through this list and see if there is a 0. There may be, there may not be. If it does cross the x-axis, and if it crosses at a rational number, then it will be in this list. But see, it could come down and cross only at irrational numbers, in which case this list and this theorem really isn't of that much help to us. But it does help quite a bit when it is a rational 0 as far as giving us a starting point, because we don't have any other type of method, like an x method or anything like that, to factor these polynomials of higher degree. So let's just look and see if we can find a 0 by plugging in 1. Let's see, we've got 2 minus 1 minus 5 plus 2 plus 2. And hey, that's a 0 because it adds up to 0. So let's go ahead and do synthetic division. It goes 4, 3, 2, 1, and a constant, so there's no missing powers. And there was no greatest common factor among all the terms. So we're fully expecting this to be a 0 over here. If not, something's wrong somewhere. And that's what we get. All right. So now we have this x minus 1, and this gives us 2x cubed plus x squared minus 4x minus 2. Well, we don't have, well, it turns out this one looks like it could be factored by grouping, but suppose you didn't see that, suppose you didn't know that. We can use the same list and even the same 0 to try again to see if we can find a 0 for this function. So if we do try 1, we'll call R rather than P for reduced. What would we have? We'd have 2 plus 1 minus 4 minus 2, and that's not 0. What if we try 2? 2 cubed is 8. 2 times 8 is 16. Plus 4 minus 8 minus 2, and that's not equal to 0. Let's try negative 2. I don't think it would. But let's see. If I plug in negative 2, that'd be negative 8. So this would be negative 16 plus 4 plus 8 minus 2. And that's not 0 either. So let's, have we tried, we haven't tried -1. That'll be -2 plus 1 plus 4 minus 2. Right? And that doesn't help us either. All right. So I've tried 1, -1, 2, -2. Well, I'm going to have to try the 1/2. And that way, and the -1/2. You know, I avoid doing the fractions until later. Let's go ahead and do it with synthetic division, just so you can see the synthetic division with a fraction. So that might be kind of helpful. Yeah, and I think one of them is going to work now that I look at it. So let's try 1/2. We've got 2, 1, -4, -2. The 2 comes down, and half of 2 is 1. Half of 2 is 1. That's -3/2, and that's not 0. So let's try -1/2 and see what we get. Hopefully this one will work. We've tried all the others. Half of that, half of that, half of that, and there, boom, we found it. Okay, so unfortunately that could be the case. The list could be long. You could go through it, and it's the last one you try, or you try the whole thing and none of them work. But this time it did. So we have the x minus 1 that we already, in factored form, we'll write this as 2x plus 1. And now this starts with 2x squared minus 4. So this time I do see a common factor there of 2. Yeah. So in factored form, x minus 1, 2x plus 1. I'm going to put the 2 out in front. This would be plus the square root of 2 and minus the square root of 2. So let's make a table now. All of these have a multiplicity of 1. So it's going to, all of these are going to intersect the x-axis by crossing over it. None of them are going to be a touch. This 2 has nothing to do with making this product equal to 0. We mentioned that before, well, maybe in other problems. So 1 gives us a 0. -1/2 gives us a 0. Negative square root of 2 gives us a 0. And positive square root of 2 gives us a 0. Since this is of degree 4, we can have at most 4 x-intercepts, at most 4 zeros, and so this is we found them all. We know we don't have to keep searching for any more x-intercepts. We see that all of these have an exponent of 1 right there. So when you go to graph it, it's going to cross the x-axis at each x-intercept. None of them will be a touch and turn. All right, so I hope that helps, and I'll talk to you later. Bye.